Hello students, here we are looking at another rates problem, and noticing some stuff at the beginning of this. We've got a rate which water flows out of a pipe, gallons per hour, just to make sure I keep an eye on that. I'm beginning to get the idea that I should probably know about kind of the derivative of this rate and also what happens if I find some kind of an accumulation of this rate. So that would be talking about gallons per hour if we're looking at the derivative, which would be r prime. And that would be talking about based on hours and gallons per hour being in our table. If I multiply those rates together, I get gallons. Those are things to keep in mind as we go through more and more of these. The second part that I see here is this is differentiable. That means that my existence theorems can be applied, all three, because if something is differentiable, it also means that that function has to be continuous. We're then given a table that shows the rate every 3 hours for a 24-hour period. And seeing a table, I'm guessing I'm going to have to do some kind of RAM stuff, because that's what we all do. And a whole bunch of these problems, so we can expect to see that as well. Let's look at part A. We're asked to do a midpoint Riemann sum with 4 subdivisions of equal length. So if we've got 24, I've got to break that into 4 pieces. That's got to be pieces that are 6 units long. My first one's going to go from 0 to 6, and then from 6 to 12, from 12 to 18, and from 18 to 24. And each of these is going to have a width of 6. That also means that for each of these intervals, I've got to use the height at the midpoint. That's why this is a midpoint sum. So the middle one for the bottom one is 10.2. For the next one down is 11.3. The second to the top is going to be 11.2. And then the top one is going to be 10.4. Okay, and we've got to approximate the integral from 0 to 24 of r of t dt. And then I'm assuming that we have to explain the meaning of this in this interval, since we can't quite see what that is. So let's do this integral first. So we're going from 0 to 24, and that's r of t dt. And that's going to approximate as 6 times 10.4 plus 6 times 11.2 plus 6 times 11.3 and 6 times 10.2. Okay, and then as far as some kind of interpretation of this, if we're talking about an accumulation of gallons per hour, that would be the total water in gallons leaving the pipe, and that would be between time 0 and time 24. T equals 0 and t equals 24. So that's what we're approximating there. And by the way, if you want the numerical answer for this, it's about 258.6 gallons. Okay, let's look at part B. Here I see a couple of clues. Is there any time on this interval that r prime of t is equal to 0? That seems to me like some kind of an existence thing. I'm also given the additional clue of justify, which usually happens if we have to talk about EVT, IVT, or MVT. And since we're dealing with a value of r and then some kind of a rate, r prime, this is going to be an MVT thing. So the first thing I've got to say is that r of t is differentiable. And because it's differentiable, that means that we can, in fact, use MVT. So, for r prime of t to equal 0, we have to have some other interval such that r of b minus r of a over b minus a. In other words, the slope between 2 points must equal 0 as well. So in order to do that, what I'm looking for are two values that would make me get a 0 slope, and I can see that pretty quickly because we have two values that are the same height. In fact, those are the only two that are the same height. And if I take a look at r of 24 minus r of 0 over 24 minus 0 is equal 0 by mvt. Yes, there must be some point that makes that happen. Alright, then we got part C. So we got the rate at which water flows out of a pipe can be approximated with Q of t. Use Q of t to approximate the average rate of water during the 24-hour time period. So we're given the rate of water flow, and we're asked to find the average rate of water flow. We've got to be careful because we see average rate, we want to think average rate of change. But since this is the average rate of a function that is a rate, this is an average value question. So average value, we know that we're going to do the integral of Q of t dt. And because this is calculator active, this is going to be done on your calculator. And going from 0 to 24. And then to finish up, we have to divide by the width of that interval. So 24 minus 0 would give me that width. Again, we're just going to be doing this on our calculator. That's going to be doing, hopefully putting Q of t in for y1, and then evaluating that divided by 24. And when we do that, we should get somewhere around 10.784. And because this is the average value of that rate, it's going to be in gallons per hour. This was a truncation. I just chopped off last decimal. That could also be 785 if you round it up instead. Making sure I did everything I needed to. Units of measure, I got that. 24-hour time period, we are good. Okay, let's look at this thing as a whole. Going into this, we knew we were going to have to do some kind of RAM because we have a table. We ended up doing an MRAM as part of that. We also predicted we'd have to talk about units for accumulation. This happened in part A. And we had to talk about, we predicted something for units of taking the derivative of this, which we didn't actually end up using. We did have to do some MVT work here. And to do that, we had to talk about this thing being differentiable in order to get that credit. And then finally, we were given another rate function and used that to find average value. The trick here was average value was asked for by asking for the average rate. And we often associate average rate with just average rate for change, but in dealing with that, we have to be a little bit careful. All right, looking at where these points come from. In the first one, you get 1 point for appropriately identifying your midpoint values. The second point comes from multiplying all of those by 6. You could feasibly stop here, or if you had done that separately as I did, you don't actually have to calculate that value. The third point comes from the actual explanation, and usually for explanations you need what it is, total flow, units, gallons of water, and the 24-hour period. So you need time, units, and what is going on. For the second one, we have our answer, which was yes, and you need MVT, and in order to say MVT, you must say that it is differentiable. In 1999, they accepted the fact that differentiable was stated in the stem. In modern problems, if you do not state differentiable, from my understanding, you may not get credit for that. So please be very precise. For the average flow, we need the limits and the average value constant. Okay, that's 1 point just for that stuff. Q of t is the integrand, so you're getting 2 points just for that setup. Only 1 point for your answer. And then finally, you get a point for gallons in part A, gallons per hour in part C.